Okay, so 5.3 is not anything new in terms of methods for multiplying. That's why I'm combining it. So the first thing I write in 5.3 is, remember, you already know how to multiply any and every polynomial with any and every other polynomial. Okay. However, the one thing I will say is, oh yeah. As soon as we start factoring, so really this section is about two things. It's about one form and one really common mistake. So the only reason we're really doing this is preparing for the future. There's no new multiplication here. Okay, I'm going to show you a form that comes up over and over that's like, oh cool, that's a little pattern, a little trick that hopefully will eventually become ingrained because it will show up so often. But in terms of multiplication, there's nothing else. You can multiply every single polynomial ever that way, okay? But when we start going backwards, when I start giving you things like this, and we would not do this, I would not have you factor this many terms, but once I start giving you a polynomial and saying, factor it back to what it came as, that's when noticing this one common form will become helpful. So, the two forms, you would write this right below. A plus b times a minus b equals a squared minus b squared. We'll talk about why. Okay. A plus b squared is a squared plus 2ab plus b squared. Okay, and what I'll write is this one, super common, helpful. All right, this one, common mistake. Right, that's it. So we're gonna do some, like, memorize this one because it's really helpful. And this one, all I'm gonna say is, don't mess up. Other than that, there's no trick to it. Okay. So the first one, this is called the difference of squares, and you will see this so much that I really want everybody to be super helpful or super used to, calm with this form. The form is a squared minus b squared, right? The difference, this means subtraction, of, and squares is talking about perfect squares, like as in things raised to the second power. So look, here's a perfect square and a perfect square, and there's a difference between them. Okay? Here's an example. Let's take x plus 3 times x minus 3. And just multiply these together like normal in the last section. Because again, there's no new multiplication here. It's just a common form, like a shortcut that you can use. When you multiply two things together, exactly the same, but with a different sign, okay? That's when this works. Okay, so let's do it. take the x, distribute it in, take the positive 3, distribute it in, and we get x squared minus 3x plus 3x minus 9. And look at what happens. Specifically because these were exactly the same, and one was positive and one was negative, we get the middle term to be a positive 3x and a negative 3x. So the middle terms will cancel. Because they were exactly the same numbers being multiplied together, except one was a positive and one was a negative. So you get exactly the same term negative, exactly the same term positive. So they cancel out, and you get x squared minus 9. Okay, let's do a couple more examples. What they want you to do is to start using a shortcut. If you don't want to, I would say practice it anyways, even if it's a little uncomfortable in your skin, because later on it will be very useful. Here's 20, that's 25, I did an odd one for you. Okay, well let's do 28. Now we've got 2x plus 5 times 2x minus 5. So notice, both the numbers are exactly the same, but the sign in the middle is different. So here's our formula. A plus b times a minus b equals a squared minus b squared. So this is going to be something squared minus something squared. What goes in the first parenthesis?
2x.
Yeah, that's our a. And 5 is our b. See? A plus b, a minus b. So we take that a, that 2x, it's equal to a squared. Minus, we take the b, which is 5, right? And that's our a squared minus b squared. So we're using a formula that rarely in this class do I say it's good to memorize a formula. But I would say it's good to memorize that one. Okay? And so that's equal to 4x squared minus 25. Again, you could just multiply it out, you'll get the exact same answer, but this form is super helpful, super common. Okay, let's do another one. Things get more complicated. Let's do 34. So 34 says 4 minus 3y times 4 plus 3y. So what's that going to be equal to?
4 squared minus 3y.
Exactly. 4 squared minus 3y squared. So we get this is equal to 16 minus 9y squared. That format is going to be very useful.
Does that only work when they're the same four numbers though?
It only works when these two numbers are exactly the same as these two numbers. One's a subtraction, one's addition. But the order doesn't matter because you're multiplying. So it could be 4 plus 3y first, minus second, or reversed.
So it's 4 minus 3y times 5 plus 6y.
Yeah, no, it doesn't matter. If all of this is the same, except this was 2y, it doesn't work. You have to multiply it out, you get a middle term, it'll be maybe 16, and then some number of y's. Yeah, it doesn't work. It has to be exactly the same. Okay, let's see it get a little bit harder, right? There's not much more we can throw at you. Maybe we could throw in some powers of x or some fractions. So let's do a fraction problem. 36 is 3y plus 1/3 times, the second one has to be 3y minus 1/3. So this would be equal to 3y squared. Yeah, 1/3 squared. And it has to be a subtraction sign in the middle, that's why it's called the difference of squares. So 9y squared minus 9. Right? I'll just write the other one here and give you a second to do it. This will be the last one of this type, and then I'll mention one other type of problem. 42. 2 minus s to the 5th times 2 plus s to the 5th. So try that one on your own for a second. So what will we get as our answer?
4 minus
Squared.
2s s to the 25th power.
So we're all close, we got the right idea. So it's 2 squared minus s to the 5th squared. Right, that's our a, that's our b. So it's a squared minus b squared. Now, people are messing up here, which is totally understandable. We just started that Friday. There's a lot of room for practice and learning here. S to the 5th squared would be s to the 5th times s to the 5th, or 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5. So total?
10.
Yeah, that's s to the 10. The shortcut being you can
Time.
multiply these, but again, shortcut is where so many people make mistakes. So I say write it out, avoid it, but you know. So 4 minus s to the 10. So the only thing I'm going to mention about this second one is the square of a binomial. Oops. This is the second section. There's not much to say here. The big common mistake is a plus b squared is not equal to a squared plus b squared. That's it. That's the super, super, super common mistake that people will make over and over and over, and you think like, I wouldn't do that. You will. Everybody will. Alright? I wish it weren't so, but that's a really common mistake. Okay? My notes are, write it out twice and multiply. Okay, so if I have a plus b squared, and I'm not just saying this, literally every time I see that, I write that is a plus b times a plus b, and then I actually multiply it, because that's what's happening here. So you multiply a into both of these, b into both of these, and you get a squared plus ab plus ab plus b squared, which is a squared plus 2ab plus b squared. Okay, and it's that middle term, that plus 2ab, that's missing up here, and that's what makes it wrong. Okay, I'll just show you visually and then do an example or two, but really all I'm saying is avoid that one mistake. That's it. Just multiply it like normal is all I'm saying. So an example of that would be something like 48, which is 5x plus 2 squared. Okay, when I see that, I write it out. I say, okay, this is 5x plus 2 times 5x plus 2, and then I just multiply it out, just like 5.2, no differences. This one times both, this one times both. 5x times 5x, 25x squared, 5x times 2, 10x, 5x times 2, plus 2 times 2 is 4. Combine my like terms, and I'm done. Nothing special. Okay, but what you absolutely cannot do is say this is not equal to 5x squared plus 2 squared. Definitely not. Okay, going back to that area of the rectangle really quick, why it isn't is like this. If this side is a plus b long, and this side is a plus b long, let's say this is a and b, and this is a long and b long, then if I find the area of this, I would say this has an area of a squared, this has an area of b squared, but there's also this wide open area too that you'd be missing. This has an area of AB, this has an area of AB. So when I find the area of this, which length times width is a times b plus a times b, or a plus b squared. Right, that's the same thing as adding up all the pieces, a squared plus ab plus ab plus b squared. Right, and these are the pieces you'd be missing. Okay, so I just want to really reinforce that you absolutely cannot distribute in an exponent when you have two terms, okay? That's it, okay? As an interesting side note maybe, the reason we always turn mixed numbers into improper fractions is actually what we're doing when we have 2.5 times 3n⁵, is we're really saying 2.5 times 3n⁵. So if you wanted to multiply two mixed numbers and do it correctly without turning into improper fractions, you would have to multiply a binomial times a binomial and write 2 times 3 plus 2 times 1/5 plus 1/2 times 3 plus 1/2 times 1/5, which is just crazy, right? No one would do that. Instead, you would rewrite this as 5/2 times, rewrite this as 16/5, and then it's a really easy problem, right? So that's the reason we always say get rid of mixed numbers, is because you have a binomial. Binomials suck, right? We try and avoid them at all costs, but sometimes we're stuck with them. All right, so that's it. So that's 5.3. Again, one format, one common mistake. Other than that, we're gonna practice for the test for the next hour.